All right, today we're going to talk about how to make a position time graph. Now, so far, we know that if I give you a position time graph, you should be able to make me a mathematical equation, and you should be able to explain to me also or what an object is doing. Okay, but if I give you the words, can you make a graph? If I give you an equation, can you make the graph that goes with that? So this video is hopefully going to help you do both of those things. Okay, so first things first, going from the mathematical model to a position time graph. All right, so we've got a few clues here as to what this graph might look like. We know that it will probably be a direct relationship because it's got a positive slope here, right? And we've also got a y-intercept here, 3 meters, okay? Now, you have to know where the y-intercept is. It intercepts the y-axis, or here, the position axis, at 3 meters, okay? So that's going to be your first dot. Try my best to aim here, okay? And the next dot comes from the slope. For every 1 meter, I know it looks like this right now, okay? But we can really write this slope as, for every 1 meter, there is 2 seconds. Okay, what does that look like? Well, we do this math thing from algebra where you do rise over run, right? We have a rise of 1 meter and then a run of 2 seconds. Okay, so that's how it tells us this line acts from point to point. All right, so I'm going to start off with my 3 here, and I'm going to rise 1, and then I'm going to run 2. That puts us here. Okay, rise 1, run 2. Rise 1, run 2. Okay, and then we could just connect our points. Sorry, it should be straight. And there's our line. Okay, so that's how you go from a mathematical equation to a position time graph. Let's go with the words now. Okay, here. Zebra starts with a position of 10 meters. It then runs in the negative direction at 2 meters per second for 4 seconds. All right. So we've got clues here. It's our numbers. We've got starting at a position of positive 10 meters. All right, what does that look like? It starts, right? It starts, so at time 0, it's at 10 meters per second. Then it runs in the negative direction at 2 meters per second for 4 seconds. Okay, let's just rewrite that slope again. 2 meters per second. I know it looks like this, but really, I can rewrite it like this. 2 meters over seconds. Okay, and we know for fractions, I can put a 1 down here and not really hurt anything, right? Okay, now you're thinking, well, that's a slope, right? But it looks like we messed up. There's no place to go up to and over 1. All right, well, let's hold on now. There's another clue here in the negative direction. Okay, so what that means is actually there's a negative 2 here. Okay, so for every second, it goes backwards 2 meters, so negative 2 meters, okay? So what does that look like on the graph? It looks like it goes, starting from our initial position, it goes down 2 over 1. Down 2 over 1. And you know where I'm going to stop? I'm going to stop at 4 seconds. Down 2 over 1. We're going to go one more. down 2 over 1. Alright, wish me luck as I connect these guys or girls. Boom. Okay. Alright, so hopefully this helped. Go practice, ask me questions, and I'll see you later.